Hey everyone, this is a review of EGO's Nexus power station that takes its EGO batteries and gives you 120 volt AC power. So I'm going to tell you what I like about this, what I don't like about it, and how to estimate runtime for whatever you want to power with it. I bought this thing about 2 years ago. I've been using it. I love it. It's performed awesome. And recently I've partnered with EGO to do a full review. So let's get started. To turn the inverter on, just hit the power button and the display lights up. It hasn't powered on the outlets yet. You have to use those buttons individually. Up here you've got the display and it's got lots of information on it. It shows you which ports you've got batteries plugged into. Right now we've just got 1 and 2. It will also show you the charge status of those batteries with that ring in the center that corresponds to the ring on your batteries. Right here in the center it will give you your expected runtime with the current load that is on the station. So right now, since we don't have the inverter on, it just shows us the maximum time. Down here, it shows you your maximum watt output capability with the batteries that you have installed at the moment. So right now I've got 2 batteries installed. It can do its full 2000 watts of output. If I take one of those off, I've got a 4 amp hour and a 2.5 amp hour. With just the 4 amp hour, you can do 1200 watts by itself. With just the 2 amp hour battery, if I take the 4 amp hour off, you've got 600 watt capability. Then if you take a 7.5 amp hour battery or bigger, by itself you've got a 2000 watt output capability. So depending on the size of battery you have, you can either do 600, 1200, or 2000 watts by itself. If you've got more than 2 batteries, 2 or more batteries, you can always do 2000 watts. In addition to the heads-up display, other buttons you have on here, you've got a reset button. If you do overload the power station, that will restart the power to these AC outlets. To access the AC outlets and the USB ports, open up their covers by pushing these little buttons right here. These are weather-resistant covers. They aren't waterproof, as is these little splash guards right here that protect the fan vents. You've got one in the front and one in the back. You can leave these ones off if you don't want to install them. If you're always using it indoors, you don't really need them here. I only put mine on because I didn't want to lose them. When you're using these USB ports, all 4 can be used simultaneously. I do wish it had USB-C, but this was put out right around the time USB-C was becoming popular, so it's just got USB-A. You can use whatever adapters you need to power things, but if you need something that's higher power USB-C, you're going to have to plug something in here to the AC adapters. To turn on the 4 USB-A outlets, just hit the USB button. You can see its status up here. Then to turn on the inverter portion with the AC outlets, hit this button and you can see it light up here. You'll also get an adjustment to its power output runtime because the AC inverter is now using a little bit of power to run the fan and to run the inverter, so that runtime drops just a little bit. Now when you're running this, you can hear the fan does get pretty loud when you've got a high load on it, and you can see your estimated load capacity with this little gauge right here. So the fan gets louder because it's cooling that inverter, and you can see how much you're reaching towards maximum if you've got lots of things plugged in. Up top here, you've got the power brick for charging. You just undo these Velcro straps. And you can pull it loose. Then under that, you've got your charger cord storage space. This pops up, it's retained, and you've got space for cables. These plug in from the power brick to the inverter, and I've got extra USB cables stored up here as well. So to turn this into a 4-bay sequential charger, it doesn't simultaneously charge them, it does one at a time. You just plug this in, line up the arrow with this because it's not a reversible connector. You can't get it wrong, you're just going to be fumbling around like a USB-A port. So this one, line up the arrows again, and then you just plug this power cord in right here and plug this into the wall. Now when you've got this plugged into the wall, you can't use it for power output. So there's no pass-through charging on this, which I think is a little bit frustrating. I wish they had made it so you could charge these batteries while powering something, and then if the power goes out, it'll be a battery backup. That would have been really nice, but it doesn't do that. So just know that if you're charging and you want to use this, you've got to unplug it from the charger, and then these will function as regular outlets. Now you see when I put the battery in here, it takes a minute to go ahead and figure out how fast it's charging and how much space is left on that battery. And then it's pretty accurate to tell you how long it's going to take to charge those batteries. So these aren't a super fast charger. This is a 10 amp hour battery right here, so it does have a lot of capacity. Usually if I've got 4 and 5 amp hour batteries that are completely empty, it'll pop up and say 8 to 9 hours for all of them. So that's another thing to note. This is total time it's going to take to charge things. So when you put batteries on it, that will go up if they're not full batteries. So it's evaluating this one and figuring out how long it'll take to charge that. I guess that was a full battery, so it didn't add anything to the charge time. The number one question or type of question I always see on inverter reviews is, can this power my TV? Can this power my coffee maker? XYZ. Everyone wants to know what it can handle. The answer for this inverter is really simple. Yes, it will power anything that you normally plug into a wall. So this has 2000 watt output capability and 3000 watt surge for like inrush current on motors when they start up. A normal wall outlet that's 15 amp circuit is 1800 watts. So this is just as powerful as your wall outlet. I've personally tested this on a bunch of different things. I've used this for power tools. I've used it to power my sump pump. I've used it for a space heater, and that's mainly just testing out its capabilities. I have found one tool that it will not run, and that is my 15 amp 12-inch miter saw. The inrush current on that is just too high, and every time I try to start the blade spinning, it will trip it out. That is the only thing I have found that it will not run. The next question you might have is, well, how long will it run whatever I want to run? That's going to depend on what you're trying to run and the batteries that you've got installed on your power station. And EGO has a really great feature on their website for this, where you can load it out with whatever type of batteries that you have and the number of batteries that you have, and it will give you expected run times for a bunch of different electrical appliances that you might want to power with it. Now, if you've got something that's not on their website, I'm going to give you a way to estimate runtime. First of all, take your appliance or electrical device and look at the bottom of it. It usually has a data plate on it, or you can look in the manual and it will say wattage draw or it will say amperage draw. If it says amperage draw, you take 120 volts times your amps and you get watts. Otherwise, just use the watts value listed. Then take all your batteries that you're going to use with it and add up their amp hours. So I've got 2 4 amp hour batteries and 2 5 amp hour batteries. That's 18 amp hours. You multiply that by 50.4 volts, which is the nominal voltage for these batteries, not 56, that's max. Use the nominal voltage. So 18 times 50.4, and that will give you your watt hour capacity of your batteries. So now you've got watt hours and you've got watts. Just divide watt hours by watts and you're left with hours. That gives you your runtime. Now there's one more thing to consider, and that is efficiency. Most inverters like this are between 70 and 90% efficient. I took my 10 amp hour battery, charged it all the way up, and put a kilowatt meter on this, and ended up with 400 watts out of this 504 watt hour battery. So it's about 80% efficient when you're looking at these batteries. So take that final runtime number you had and multiply it by 0.8, and there's your estimate. One downside of this inverter is it is very heavy. Just by itself, it's heavy. When you add a bunch of big batteries to it, it gets really heavy. It is nice that EGO has these really sturdy grab handles. You can pick it up, you can get your whole hand around them. It makes it a lot easier to move. And it's also got a really nice sturdy aluminum roll cage around it to protect the unit itself and the batteries a little bit as well. This also has rubber feet on the bottom that are very grippy. Combined with the weight of this unit, when you put it someplace, it's going to stay where you want it. One important feature about this inverter is that it is a pure sine wave inverter. And that means its output looks like a smooth sine wave, the same that you'll get from a wall outlet. A lot of cheaper inverters are modified sine waves, and when you look at those, it looks like a square wave or a step square wave. And the difference between those is the step square wave or modified sine wave has a lot of high frequency harmonics. And that can be tough on your filtering electronics for like a laptop brick or a TV. It can prematurely wear them and put a lot of stress on them and cause premature failure. On the other hand, with a pure sine wave, you don't have that extra stress. So that's really important. This can run absolutely anything that you normally plug into a wall outlet, and it can run it well. If you run a motor or something on a modified sine wave, you might get a buzzing. You'll get less efficient operation because that motor is shuffling back and forth as it's spinning because you have extra harmonics present in the waveform that aren't there in a true sine wave. So I bought this primarily for emergency backup power. And I figured, I've got all these EGO batteries. I could buy a dedicated power station, which the batteries are built into it, and you can't replace them if the batteries go bad, and you can't use that power station for anything but a power station. With this, you can use your power tool batteries all the time. You can put them on and use them for emergencies if you need to, and if one of the batteries does go bad, out of warranty, you know what? You can just replace the battery instead of having to replace the whole power station, which is pretty awesome. Uses for this in emergencies is going to be like running a sump pump. I've had the power go out before and I don't want my basement to flood, so this thing can definitely handle running a sump pump. It'll handle running freezers, refrigerators, and the really nice thing about it is it's not a generator that's gonna make carbon monoxide, so you can bring it right in next to whatever you wanna run and put it in there. You don't have to run power cords in through the windows and keep your windows open during a storm. So this is just a clean, safe option for doing that doesn't require you to run power cords all over and all through your house. So based on my experience with this, I definitely recommend it. It's been great having peace of mind for power outages, knowing that my food's not gonna go bad in my fridge and my basement's not gonna flood because I can run the sump pump off of this. So whether you want this for emergency preparedness or tailgating or camping or any other thing that you need remote power for, I think this is an excellent solution. I'll go ahead and put a link down below if you want to price this out. I bought mine bare tool just because I had a lot of batteries, but it's also an excellent way to get more batteries if you're looking to build how many you have. Buying the kit is usually always a better value than buying bare batteries.